Good afternoon, everyone, and welcome to week 4 of the ConsoliDator MasterClass. First of all, I just want to make sure folks can hear me. So if you could either raise your hand or just type something into the chat box just to make sure I'm not talking to a void. All right, cool. I can already see a bunch of folks have raised their hands, so thank you. Appreciate that. Alrighty, so we are going to start a minute early, because why not? We're all here. So the first thing I want to do is just make an announcement about the email I sent out yesterday. There was a bit of confusion, so I just wanted to clear a couple things up. Number one, after next week's session, which will be week 5, I will assign a midterm exam. Now, I'm calling it a midterm exam, but it's not an exam that you would normally think of. It's only 15 questions. It's nothing too major. And all I ask is that you use best judgment and that you put your best effort forward in answering the questions. I'm not going to really take points off for not selecting the right answer or anything. So there's that. So I'm going to assign that next week, and it will be due after our class on the 13th of September. Before that class happens, we are going to have a makeup session. And that makeup session is available to anybody who wants to join, and it is not mandatory. You can join if you like. It could be a review for you, or if you've missed a couple sessions, it's a great time to make everything up before the midterms are due. So on the week that the review session is, it's on a Thursday on the 9th of September. We do not have our normally scheduled Monday class that week because it just happens to be Labor Day. So if you do decide to join us for the review session, then you're not going to be doing double the work. You won't have 2 classes that week, and we already have a few folks signed up for it, so it should be a good time. So with that said, if you still have any questions, concerns, or anything, or if what I said wasn't clear enough, just reach out to me and let me know, and I'd be happy to clear it up. So moving on to this week's topic, we're going to talk about miscellaneous applications. And there's a reason why I consider all of these miscellaneous applications. Basically, they're all important applications, but there's just not enough material for me to do an entire section on, let's say, temperature measurement. So I took a lot of these honorable mentions, if you will, and I put them all on one session, and that's what we're going to look at today. So today's key topics are going to be pressure monitoring, leak detection in regard to pressure monitoring, temperature monitoring, pH and other analytical applications. We're going to take a look at some speed. And then finally, we're going to look at some timers and scheduling, which is actually going to be my favorite section here. So without further ado, we have our first poll. And the first poll is, which application type is your favorite? I have a feeling that level is probably going to be the winner, but we'll see. You guys have surprised me in the past. All right, that was right. So level is by far everyone's favorite application, which is great. Level and flow is pretty much it. And it looks like nobody remembered Netscape Navigator, and that's quite all right. That was just an old joke I put in there, and yeah. So moving on. The first screen we're going to take a look at is our basic pressure monitoring screen. And so what we have here is we're looking at an inlet and an outlet pressure, and we're also looking at the average reading right down here in the green. So I have that in green, and also the bar graph corresponds to that average reading channel. So the inlet and the outlet pressure are being read, but we're not seeing a bar graph for those. We only care about the average reading. And so the reason why I wanted to show you this is simply because we can do that type of math with the ConsoliDator Plus. I chose average just because it's something to show you, but in reality, I could have used almost any arithmetic. I could have added the 2 pressures together. I could have found the difference between the 2. I could have found the absolute difference between the 2, meaning whether we get a negative result or not, it's always going to display as a positive number on the screen. And so there's a bunch of different configurations we can use, and I just wanted to show you that we can do math functions. Now, the math functions on the device can get much more complex, but for the sake of this class, we're just going to look at this for now. And with that, I'm going to show you my demo, like the screen of my demo. And there it is. Just to show you it works. So here we see the same thing you just saw on that slide. The numbers are almost exactly the same, except as I turn my current down, you see the numbers are going down. And we have the average reading as well. That's pretty much it. That's the pressure monitoring screen. Again, just a great way to show you that we can do math functions with this view. Now, the next screen is going to be similar to something we've taken a look at before, which is common alarms. And so for this screen, what I have here is we have 1, 2, 3, 4 different sections. Let's just assume that this is a big pipe or something, okay? And so we have 4 different pressure transducers, and they're measuring the pressure at certain points, right? And so when everything is okay, and the pressure is in a normal range, our alarm here, the one that says leak detected, says no, and it's green because everything is good. And so I did this for 2 reasons. One, to show you, just to show you again the common alarms, how they work, and how they can be applied to, any application, not just gas detection. And also because, as I've said many, many, many times, everything on this is configurable. And so the name of that channel is actually asking a question, just because I think it's clever that we can do that. Okay? And so what's going to happen when one of these sections, when the pressure drops? Well, what we're going to get is an alarm. So our leak detected alarm turns this really ugly yellow and pink color. Again, I did that just to show you we can use any colors we want, even if they look horrible. And you'll notice here, we're also looking at, it's the section A. That's the one that's causing us the problem. But someone had asked the question last week, what happens if 2 channels goes off at the same time when we have them tied to a common alarm? Well, the answer is simple. Nothing special happens. So the alarm just goes on, or off, however you want to say it, and it doesn't matter how many channels go into alarm. And so let's take a look at what this looks like on my demo screen. So again, we can see here that we're reading the 4 different sections, section A, B, C, and finally section D over here. Everything is good, so our alarm is green, but if our pressure begins to drop a little bit, and then section A has an alarm, well, now our leak detected alarm is triggered. And again, just to show you that nothing special really happens when we have more than one channel going into alarm at the same time, I'm going to make section D go into alarm as well, and you notice nothing has happened. Now, does that mean we can't have something special happen? Well, of course we can. We can, do programming to extend this and to make something special happen if we get 2 alarms on the same. But generally speaking, when it's programmed like this, nothing happens. And as usual, when our pressure goes back to a normal rate or a normal set point, everything goes back to normal. And so that's just one way we can use the ConsoliDator Plus as a leak detector. We have common alarms on the 5 different points, and if any of them go out, well, then we have an alarm. Now, the other thing to actually mention here, I probably should have added a slide about this. We took average pressure readings on the previous screen. Now, could we do this here? Absolutely, absolutely. If I wanted to, I could make it so that each section is being averaged together, and I can make that alarm based on if the average pressure reading goes one way or the other, we can have an alarm. So there are many different ways we can accomplish the same thing with this device, and this is just the one way that I chose to show you folks. So now moving on from pressure and leak detection, we're going to come up on the most widely measured process or most widely measured variable on the planet, and that's going to be temperature. So the first thing that I'm going to say about temperature is to remind everyone that the ConsoliDator Plus will not accept direct temperature inputs, meaning no inputs from RTDs or thermocouples. But we can accept those temperature signals if they come over as a 4 to 20 milliamp signal. And that's what most folks do when they have a device like this anyways. So what are we reading here? Well, I made the screen to show you a couple different things. Number one, that we can do temperature even if it's only 4 to 20 milliamps. Number two, we're also reading at different scales. So we have our pizza oven operating in the Fahrenheit scale. We have our bacon oven, my personal favorite, in the Celsius scale. And then believe it or not, degrees Kelvin is actually a unit of measure that is pre-programmed into the ConsoliDator Plus unit. So I decided to put that on the screen because I just thought that was kind of fascinating, because I don't know any other practical reasons to use the Kelvin scale aside from expressing really, really, really cold temperatures. And so I decided to show you the fact that we can do that, and I actually have a bunch of decimal places to show you. So I'm not sure of the exact number, but with outer space, the temperature is around 4 Kelvin. Could be a little more, could be a little less, but it's around 4 Kelvin when you're outside of any habitable zone of a star. And so that's all I wanted to show you, is just the fact that we can do temperature and the fact that the Kelvin scale is here. Oh, and about the decimals. I forget how many I programmed on this screen particularly. It might be 8 or 9, but altogether we can have up to 12 decimal places. And so a question had come up a few weeks ago about rolling over on the totals, and the reality is we can fit so many numbers and decimal places on the screen that you're never going to really have a rollover. 12 decimal places is quite a few. All right. So now moving on from temperature, I have another poll for you. So let's see, I can't read the entire question because it's cut off on my screen. So 0 degrees Kelvin, also known as absolute zero, is measured to use deep outer space. I really wish I remembered what that full question was. So here's an interesting science fact for everyone. So the Kelvin scale is used to measure temperature of outer space and other things, I'm sure, but that's just how I know it. And 0 Kelvin is also known as absolute zero, and it's the point at which, theoretically, everything freezes, including light, right? And so I was actually watching a video, and 0 Kelvin, although theoretically possible, is actually not practically possible because of the laws of thermodynamics. So I just thought that was kind of interesting. Alrighty, moving on from science, we're going to take a look at pH measurements with the ConsoliDator Plus. Now, the first thing I want to point out is when folks use this product specifically for pH, they're usually using Modbus and not the direct outputs from the pH probe. And same thing with other analytical equipment. There have been some other analytical applications where the sensor gets plugged directly into the unit, but Modbus tends to be what folks have used in the past. And so what we're looking at on this screen is we are reading the pH, right? So we got that in the pink there, pink and black. We're also looking at the sensor life and days in service. So this bar graph represents the sensor life, okay? And so I set this up so that when that sensor life gets down to that A2 alarm marker, it's going to throw some sort of alarm, or it's going to turn yellow, right? And the reason why is because that pH probe clearly needs to either be cleaned, replaced, or calibrated. And so the ConsoliDator Plus can actually do that, where we can alarm based on how long the probe has been used. So if it's been used for, let's say, more than 30 days or however long the probe is rated for, the ConsoliDator Plus can at least let you know. And again, these parameters are usually coming over on Modbus, and we're just displaying this. So the ConsoliDator Plus isn't calculating how long until you need service, although we could do that, okay? So again, this is all from Modbus, but we do have ways to be able to keep track of how long something has been in service. It takes a little bit of clever programming, but we can do it. And so the reason why I wanted to show you this screen is simply because it's a way for, well, it's a way for you to make sure that your customers are calibrating the probes. If you're selling pH probes and you want to make sure they're calibrating or buying new ones, this unit is great for that because it lets the customer know when it's time to call you. And if we want to get really clever, I could actually set up a couple different alarms here so that when we do go into alarm and they need calibration, we can have a little message pop up that says, call so-and-so, and maybe put your phone number there. So just something to keep in mind, that if you're out there talking about pH or other analytical applications, the ConsoliDator Plus can still be used for it. And this is just one of the many reasons why. And so there's really nothing to share on the demo screen. I'm going to show it to you anyways, just so you can see what it looks like on a real unit. But everything on this channel is static. Everything is just, nothing is going to move even if I change my 4 to 20. But just to give you an idea of how it looks on the real screen. Now, with that, we're going to take a look at another type of application, and it's pretty interesting. So I'm going to start this off by saying the ConsoliDator Plus can accept pulse inputs. Now, when we usually hear about pulse inputs, when I say we, I mean me, other folks at Precision Digital. When we hear pulse inputs, usually we think about flow because we're getting pulse signals from a flow meter. And so if you were to go look on our website, you're going to see that we do have pulse input panel meter totalizers, and they're labeled as flow totalizers. But essentially, all these things are doing is just counting pulses, right? So why can't we use this as a tachometer? And the answer is there is no reason. So I set up this screen just to show you the fact that we can actually use this as a tachometer if you wanted to. So we're keeping track of the intake fan rotations, the motor speed, and even though this isn't technically a flow application, we can actually totalize the fan because the units are, in the time base, we can actually totalize on that. Now, the one thing I will point out about this is the fact that these units that I created, the rotation per minute, revs per minute, and then rotation, those are all custom units. Those do not exist in the ConsoliDator Plus as a pre-programmed unit. So I had to make those up. But just another great reminder that, again, this unit is so flexible, we can make up literally anything. I've had tanks reading in bacon. I have had weird engineering units, and we're even totaling the revolutions of an intake fan on this screen. So without further ado, I'm going to show you what this looks like on my screen, or on my demo, I should say. So right now we're reading 0 on everything, and there's a reason why, because I'm not pressing the button. So this button, this push button here, is actually connected to the pulse inputs on the device. And so when I push it, we get a rate and our total. And as you can tell, my K factor, I think, is 2, so we're not going up by just one click on the rotations every time I press the button. And if I go faster, we can even have an alarm so that if your intake fan is running way too quickly, well, we have an alarm for that. And as always, if I want to reset that total, all I have to do is press the reset total button and we go back to 0. So just a really quick way to show you that even though we talk about pulse inputs being from flow meters, we can use it as a tachometer. So I thought that was a pretty clever screen to show you. And it looks like we have one more poll. And the poll is, did you know that the ConsoliDator Plus can also be used as the world's most expensive alarm clock? And it looks like some of you actually got it on Amazon yesterday. I'm glad. They just added that to their store, so I'm really glad that you guys got that on time. And some people are saying, what? No, because what the hell am I talking about? ConsoliDator Plus is an alarm clock. Well, I'm going to show you what I mean by that on this next slide here. So at the beginning of the class, I told you one of the things we're going to look at is timers and scheduling. And when I said scheduling, I literally meant scheduling. What we have here on this screen is I'm looking at a real time clock, and I have two timers. One's just timer, the other one's alarm. I'm going to explain what those mean in a minute. But this real time clock here, this is the first product made by Precision Digital that has a real time clock that can be used for something. It can be used to perform a meter function, or it can be used to perform pretty much anything. What I mean by that is the only other product that had a real time clock is one of our flow totalizers. And the only thing that time clock was used for was data log. That's it. And that was fine for that product. That's all people needed it for. But with this product, we added a real time clock, and we're actually able to program with it. And so, I mean, as you can see, it's an object. I assigned it as an object on the screen. So it's not just a clock that we have that can be useful to tell time, but it can actually become an object that we use in our program. So I thought that was pretty cool. And we're going to get to the scheduling in a second. First, I want to show you this timer. So I have two timers that are starting at 0, okay? And what's going to happen is when I press the reset total button, reset timer button right there, my timer is going to start at 10 minutes and count backwards. And I'm going to show you exactly how that looks right on my demo unit. So as you can see, everything is 0. But when I press this reset timer button right here, the timer starts at 10 minutes, and it starts counting down to 0. Now, I can have that timer start at any interval of time and count down. I can have it start at 0 and count up. Doesn't matter. It's fully flexible. I can also program it as a stopwatch if I wanted to, meaning if I had it as a stopwatch, I could press a button to do lap times. And again, just like with the real-time clock, the timer can actually be used as an object, and it can be used in our programming. And I'm going to show you exactly what I mean right now. So this alarm timer down, that's just sitting there doing nothing until we get an alarm. Okay, so here's what I'm going to do. I am going to lower the 4 to 20 milliamp signal to a point where we get an alarm. There we go. So you see the alarm right there. And now the timer is counting up from 0. Now what's going to happen is when this timer gets to 30 seconds, it's going to turn red, flash, and do its alarm thing, right? Now what does that mean? Well, it means that this alarm has been going off for 30 seconds and nobody has acknowledged it or fixed the problem. All right, so there you go. You see 30 seconds, we're flashing, and it still counts up, right? It's still going to count up until our alarm condition is clear. So check this out, right? This alarm is actually here. Oh, I'm sorry, it's this, the leak detected alarm. That's the one that timer is connected to. So watch. If I return back to normal and there is no leak detected, then our timer goes back to 0. It stops, resets, goes back to 0. So let's look at that again. I get an alarm. My timer starts counting up. I'm going to clear the alarm now. And it goes back to 0. So why did I show this to you? Well, one thing I have had people ask me over the years is to be able to time how long an alarm has been active. So if somebody, you get a high tank alarm, and an operator ignores it or walks away or forgets about it or whatever the reason is, they walk away from it, the tank is left unattended. Well, people have asked me if there's a way to keep track of how long that has happened for. and to be able to, see how long it takes to fix a problem, right? And so what we can do with that is we can actually have that alarm timer. We can have that go to a bigger alarm that's in the plant. We could have that send a signal to the control room, letting them know that the alarm is still active. Or we can actually data log those alarm timers. So if we data log that, let's say it was over the weekend, right? And we want to see how many times the alarm has gone off and for how long it ran each time. We can do that with the data log. So it's pretty cool. It's a really cool feature to be able to time how long an alarm has been on for. Now, I'm just talking about alarms. We could trigger that timer based on anything. So, for example, let's say there's no alarm, but I want to know when the pressure drops below 50 psi. And when it does, I want to know how long it does. It's not an alarm. It's not a dangerous situation, but it's something I want to know. Well, I can have an alarm be triggered by a process variable. So the possibilities are really endless. And this is just one small example that I wanted to show you. And so with that, that is the end of the class for today, for this week. So you folks are free to go. I am going to answer questions. We did have a few pop up during the presentation. So as a reminder, feel free to stay. I won't be mad if you go. Again, next week is going to be combining applications. So we're going to take a look at how we combine different applications onto the same unit. And again, I'm going to assign the midterm exam next week. It's going to be due on 9/13. We have a review makeup session on 9/9 for anybody who wants to join. Again, not mandatory. So with that, I'm going to take a look at some questions. All right. Let's see. So somebody asked, can you read pressure and temperature simultaneously? So the answer to that question is actually going to give away the secret for next week, but the answer is yes. So I did this on purpose. I designed the class purposely so that we're looking at one application per week, with this class, with this session being an exception. And so next week, we're going to take a look at how we can actually put multiple applications on the same unit. So even though we were looking at level applications, this can be used to monitor level and flow at the same time. Or in this case, with this question, we can monitor the pressure and the temperature simultaneously. And what's actually really nice is I have a really awesome screen for next week to show you the pressure and the temperature specifically going together. So it's pretty cool. So the answer is yes. Someone else asked, do we have an alarm history screen? Well, I have to think about that for a second. The answer is no. We don't have like a screen you can go to that'll show you all of your alarms or whatnot. But as I mentioned in the last part of the last slide, if you wanted to, you could data log these things. So when an alarm is triggered, we could make that be the trigger for data log. And so it's not something that comes standard on the unit, but we can do a history of alarms in a roundabout way. So hopefully that answers your question. Let's see. Someone had asked me about the inputs when it comes to the frequency or to the, how do I say it, the speed measurements. So I've mentioned before that the pulse inputs on the device can be used as a digital or discrete input. It is not true. The inverse is not true. What I mean is when we're talking about using this as a tachometer, we're going to want to use the true pulse inputs, not the discrete or digital inputs. So that's a good distinction. That was a great question. Someone else also asked with the pH, it was coming from Modbus, but can I take a direct input from a pH probe? Well, the answer is if it's a 4 to 20. So if it's a 2 or 3 wire sensor, More than likely, yes, as long as it's 4 to 20 milliamps. I'm not a pH probe expert by any stretch of the imagination. I don't pretend to be. But from my understanding, a lot of the probes do have a ton of wires that come out the back. And so from my understanding, it's a little bit of black magic to get those things set up. So I'm going to stick with the answer that if it's a 4 to 20, yes, but more than likely it's going to be 5 plus. Someone also asked, can I trigger the timer via digital input? And the answer is yes. So as I had mentioned before, the timers can be triggered based on practically anything. So they can be based on a digital input, so a physical feedback from an operator. They can be triggered on time of day. Actually, that reminds me. That's something that I totally glanced over, and no one yelled at me for it. So the scheduling, I meant to go back and talk about the scheduling. This ties into this question here. So with the scheduling, not only do we have a timer, but I have a real time clock with a date. And so what I can do is I could actually start that timer on, what is it today? On August 24th at noon, I could start that timer if I wanted to. Or let's say, for example, I want to reset my totals every day at midnight. I can do that with the scheduler. Let's say I want to turn a pump on every Saturday and Sunday at 3 p.m., but only for 45 seconds, and only if the level is above 10,000 gallons. I can do that with the scheduling. So again, that's just how flexible this device is. The answer to almost all of your questions is yes. I just have to figure out a way to actually do it, to tell the machine to perform that. That was a really great question. And I think that might be everything. Someone else asked a question about the real-time clock and if it can remember the time when it's powered down. So the answer is yes. The real-time clock is run by a lithium-ion battery. So it's, if the power is off to the unit, the battery is still keeping track of time, or the battery is still helping keep track of time. That's going to come with another question with how long is the battery life, and I don't know. I'm not sure what the battery life is. I would assume it's long enough that you're not going to have to worry about it dying within the first couple of years. Usually we rate things for 7 to 8 years, so I'd imagine it's the same, but I'm not entirely sure. Someone also asked, is there a session planned to review the software? That's a really great question, because that gives me the opportunity to let you know that, yes. So the reason why I'm doing the midterms, the reason why I'm making a big deal about the midway of the class, is because starting on week 7, we're going to talk about nothing but the software and how it's configured, best practices, how to step through the software and program for the applications we looked at. In order for me to do that successfully and have it make sense for everyone, I had to go through all of these features and show you how they work, right? That only makes sense. I show you how they work, why they can be used, and then starting in 2 weeks, I'm going to show you how we make those things happen. So yes, we'll have plenty of time to look at the software. In the meantime, if there's anything you want to learn about on the software or any extracurricular learning you want to do on the ConsoliDator Plus, please feel free to ask and just give me a call. I can talk about this device for hours, as you can tell. Can you reset the total at a certain time and log the daily total? You know what? I'm going to have to, I think the answer is yes, but I'm definitely going to have to test it out for you and figure it out. So again, the question was, can you reset the total at a certain time and log the daily totals? So that's a great question. I think the answer is yes, but I'm going to test it out and let you know. All right, folks. Well, that's all the questions I had today. And some folks are starting to sign off, which is fine. We're getting a little past time here. So again, really appreciate everyone's attendance. You'll receive the study guide and the slide deck after this session, and the session will also be put on YouTube momentarily. One last thing, the first 3 sessions are on YouTube right now. So if you want to go back and review them, or if you just can't get enough of hearing my voice on a webcam, go ahead and watch them on YouTube. So we'll see you next week, and have a great day.